A very good morning. In the last class, we were discussing about the various concepts of sampling, and one concept we were yet to discuss, which is very important in the parlance of sampling, which is known as sampling frame. If you remember, I told you that the population or universe, if this is this, then a sample is a miniature model of the population or universe, which will possess all the essential characteristic features which the population possesses. And now when we talk about sampling frame, I will give you an example while discussing about the universe, and if the topic of our research is media usage habits, suppose it is media usage habits of Tezpur University students. Now our population as such is the Tezpur University students. This is the universe. And as we know, the Tezpur University is essentially a residential university, where about 99% of the Tezpur University students who are regular students of Tezpur University are staying in the hostels. But if you take into account the number of Tezpur University students, it will be around 5,000 students, out of which 4,000 students have enrolled themselves in regular courses and attending classes in face-to-face mode, and about 1,000 students are studying through distance mode, and they are the students of Center of Distance Learning of Tezpur University. And these 1,000 students, they do not attend classes regularly. They are being given e-resources, they are being given study materials, and they have been asked to attend for 15 days the contact classes in a semester. So the mode of delivery of instruction to the regular students is completely different to the mode of delivery of instructions to the CODL students. Now when we make a study of the media usage habits of TU students, we are looking at the students who are normally staying in the hostels, which is about 99% of the regular students. So our population total population is 5,000, but the sampling frame from which we will take our sample is 4,000. This is the element of homogeneity is there. Means the population is heterogeneous, and if you take into account the mode of delivery of instruction as another element of differentiation between the population, then this is 1,000 is CODL and 4,000 are regular students. So these 4,000 students, we have been able to identify them, we have been able to assign them with numbers from 1 to 4,000. And this is known as 5,000 as population, this 4,000 as population sampling frame, and this sample that we take of 1,000 or 500, whatever it may be, this will be taken from this sampling frame. So whenever we talk about sampling, the three things that come into our mind is, one is universe, is the total defined universe, and from the universe we will take a sampling frame where the element of homogeneity we will find. And there is an element of heterogeneity between these 4,000 regular students and 1,000 CODL students. And we will be confined to our study for about these 4,000 students, and that is known as the sampling frame. I will give you another example. Here, suppose we are making a study of the impact of media on the CAA coverage, on the Tezpur University students. the CAA Citizen Amendment Act, or whatever we call the NRC or the NPR, this is a concept, this is a matter which is related only to Indians. Our Tezpur University students population is about say 4,000, and out of which about 39 foreign students are studying. And foreign students do not have any relevance to the NRC, to the CAA, that is of no use for them. So collecting information about the CAA or NRC from these foreign students will be of no use to our study. So our here the sampling frame would be 4,000 minus 39 foreign students, that will come about 3,961 students. This will be our sampling frame here. From that we will draw the sample. So there are, what I mean to say, when we have a population that is always heterogeneous in nature, and depending on our purpose of study, we will have to construct a sampling frame by delineating, by eliminating the heterogeneous, smaller heterogeneous groups which do not have a relevance to our study. And the rest would form the sampling frame, and from the sampling frame we will have to draw the sample. That's what we consider and we mean about sampling frame. And besides sampling frame, there are certain assumptions also. When we want to study sampling and when we want to draw a sample, the sampling is based on certain assumptions. And there are basically three assumptions on which sampling is done. The assumptions based on which sampling is done. And there are three assumptions actually. One is homogeneity. Homogeneity. Two, possibility of representative sampling. Possibility of representative sample. And three, where absolute accuracy is not essential. Absolute accuracy in the findings is not essential. These are the three things, three assumptions basing on which we will have to draw the sample. Now homogeneity. Homogeneity, you see, you take any sample that will be heterogeneous in nature. Say for example, Tezpur University students. That is a heterogeneous population comprising of males and females. That's a heterogeneous population comprising of students from different states of the country. Comprising of students, the Tezpur University students, they belong to different streams of study, disciplines. Some studying discipline, science, some are studying humanities, some are studying social science, some are studying management and commerce, some are studying humanities. So, and some are studying engineering. On the basis of disciplines, they can be grouped. Now what I mean to say, when we talk about homogeneity as an assumption, basically a population is always heterogeneous in nature. A heterogeneous population comprising of various homogeneous groups. A heterogeneous population always comprises of various homogeneous groups. And we need to identify those homogeneous elements within the heterogeneous population. And from each homogeneous group, we will have to take a smaller group, and when you add all these smaller groups, these groups will constitute our sample. So unless there are elements of homogeneity in a heterogeneous population, sampling will not be possible. That is the first characteristic feature, that is the first assumption. Second, possibility of representative sample. Now suppose within this Tezpur University, now the sizes of the various homogeneous groups, they are of too much difference. Suppose one size is 3000, another group is only 19 students, another group is only 5 students, another group is 529 students. Then you see one homogeneous group is 3000, another homogeneous group is 19, another homogeneous is 5. So the sizes are, the variance in the sizes are too high. Now when these sizes of homogeneous groups vary very highly, then it becomes really difficult to take or to get a representative sample. Normally, in a heterogeneous population, what we will have to search for is that the sizes of homogeneous groups would almost be similar or equal or on the same level almost. Then only we will be able to draw a representative sample. That you must remember. If you have 5 members of one group, then it might so happen while drawing a sample through scientific methods, we will not be able to include any of them. Now then we are leaving one group, homogeneous group, out of our sample. Then that is not representative. So the second assumption is that the sizes of various homogeneous groups should be more or less equal so that we will be able to draw a representative sample. Third assumption is absolute accuracy is not essential. Now media usage habits, I gave you the topic. If we make a study of the whole census, all the 4,000 students, and if get the findings that every student spends about 30 minutes on newspaper reading, every student spends about 1 hour 15 minutes on television viewing, every student takes about 3 hours for internet usage. Suppose this is the finding we get from studying the whole population of a census survey. Now, after taking a representative sample, if our findings comes that it is 29 minutes, it is about 1 hour 10 minutes, and it is 3 hour 15 minutes. This is not a big difference. You see, accurate, it may not be accurate. 30 minutes have become 29, 1 hour 15 minutes have become 1 hour 10 minutes, 3 hours have become 3 hour 15 minutes. That doesn't make a major difference. Here also we can conclude that the majority of the students, they spend more time on internet usage, and the second most important medium for their usage is television, and the least time they use or they utilize on newspaper reading. In both the cases, the conclusion would be same, but the data would be about somewhat more or less equal, but may not be the exact data. So what we say, in sampling, absolute accuracy is not essential. Where you are trying to find out a trend, where you are trying to find out how much of the percentage of population spending time, how much of time on each medium, then that is absolute accuracy is not essential actually. So that is, if that is the case, then perhaps sampling would be the most appropriate method of studying the social phenomena, studying the communication problems, studying our economic problems. In social science research, sampling perhaps is the most appropriate method if we are able to draw a representative sample within quotes. Now, we have talked about the concepts that we had. Now, if you talk about why do we go for sampling? What are the advantages of sampling? What are the disadvantages of sampling? And when we talk about the advantages and disadvantages, mostly the advantages outweigh the disadvantages. The advantages, the most important advantages, it saves time. It saves time. It saves money. It saves money. It allows for detailed study. If you are studying less number of sample units of the population, then you can make an in-depth study. There is less, if it is a representative sample, there will be less biasness. Less biasness. You will be able to remove the difficulties of a census study. You will remove the difficulties of a census study. So, normally, particularly for student researchers and PhD scholars researchers, these are very important. They will have to complete their study within a specific period of time, within a specific amount of money, because money is not being given to them, and those who are getting fellowship, that is also limited, and time frame is limited, and there is a possibility of detailed study and biasness. If scientifically you draw the sample from the population, then biasness will be less, sampling error will be less, and finally you can remove all the difficulties of studying the whole population. These are the advantages of sampling. Now, when we talk about the disadvantages, the most important disadvantages, the personal biasness. If you will not apply scientific methods while drawing the sample, if you will act upon your own intuitions and personal judgments, then you will not be able to get a representative sample. So there will be a lot of personal biasness in the sample, and the findings will be biased findings. Second disadvantage, major disadvantage of sampling is that non-availability of the sampling units. Non-availability of the sampling units. The sampling, the units that you have chosen to form your sample, at times what happens, those sampling units, those people are not available when you go for data collection. And you keep on going to them number of times and they are not able to give you time, or you are not able to meet them. So, non-availability becomes a major problem for a sampling research. Third, non-response. When you suppose you send a questionnaire, and if you have sent a questionnaire to your 400 respondents, and today the non-response rate is almost 30% to 40%. And when the non-response rate is high, naturally the findings will not be valid. The findings will have lot of biasness. The findings will not be universalized, will not be able to be universalized. Another problem, when there is non-availability, what the researcher does, he changes the sampling unit. If suppose X has been selected in the sample, and X you are not able to contact or collect data from X, then we are changing that sampling unit with either Y or Z. So this change of sampling unit brings in lot of error into the study. These are the major disadvantages of sampling. Now here, we have understood the basic things about sampling. And I have also told you in the last class regarding various sampling methods. I had told you about the probability sampling and non-probability sampling. These are the two major methods of drawing sample: probability sampling and non-probability sampling. Now, when we talk about probability sampling, what does it mean? Probability and non-probability. As the name goes, probability sampling means where each unit will have some probability or chance of being included in the sample. Each unit of the population will have some probability or chance of being included in the sample. Non-probability, that probability of being included will be missing. You never know which element will be included in the sample, which element will be eliminated from the sample. It is all based on personal choices and convenience. So probability sampling is perhaps the most scientific method of sampling which we are using in social science research when we want to get the validation or credible results from our research study. Now, probability sampling, the most important probability sampling method is known as simple random sampling. There are 6 probability sampling methods. Simple random method. Second is systematic sampling. Systematic sampling. Third is cluster sampling. Cluster at times is also known as area sampling. Fourth is known as stratified sampling. Stratified sampling. Fifth is, as you know, that is known as quota sampling. And the 6th method of probability, that is known as multi-stage sampling. We will discuss all these types of methods of sampling in details. Multi-stage sampling. And when it comes to non-probability sampling, the most common method of non-probability sampling, what we call, is the convenience sampling. Convenience sampling. Second method is known as purposive sampling. Third method is known as snowball sampling. Fourth method is volunteer sampling. Fifth method, where I have explained it to you that quota sampling is a probability method, and I will also tell you that quota can also be a non-probability method, quota sampling. So these are the 6 methods of probability sampling, which are known as simple random method, then systematic sampling, then we have the cluster or area sampling, fourth is our stratified sampling, fifth is quota sampling, and sixth is multi-stage sampling. These are basically and mostly used by the scientific researchers engaged in social science research. But these probability sampling methods are used only when we have a definite universe. We have a well-defined population where we are being able to identify each element of the population. Then only probability sampling would be applied. If we do not have a defined population, if we are not able to identify each and every element of the universal population, then it will not be possible to get a random sample under probability mode. So we will have to opt for the non-probability method of sampling, which is not very scientific, and the results that we will get through the use or an application of non-probability sampling method will also not be very valid and scientifically provable. So empirically stated, the probability methods will get us results which are measurable, which are universal in nature, and which can be applied or replicated by our future researchers. But when we are using the non-probability methods of sampling, then replication is impossible, universalization of findings is impossible, and that is mostly based on our personal choices, our intuition, and our convenience. Now, we will discuss about each method of probability sample first. Then we will go to non-probability sampling. Now the first one is simple random sample. What is a simple random sample? A simple random sample can be defined as a sample where each element of the population has the equal chance of being included in the sample. When I told you about probability sampling, I told you that where each element will have some probability or some chance of being included. But when I am telling you about simple random sampling, I am saying simple random sampling method tells us to draw a sample by giving an equal opportunity to every element in the population of being included in the sample. Suppose your population is 1000 and you want to draw a sample of 100. Now how would you take a simple random sample? It's not very easy. For simple random sample, you will have to have a defined universe where all the 1000 units will be given one number, 1, 2, 3, 4, up to 1000. Okay? Now, there are three methods of drawing simple random sample. One is a lottery method, very simple. Two is a LHC Tippett's table. And three is grid sampling. These are the three methods of drawing a simple random sample. What is lottery method? Very simple. Lottery method. We all know. Now, if we have 1000 units in the population, on sheets of paper, we will write 1, another sheet 2, like 1000 sheets we will prepare. And then we will put all those 1000 sheets into a tumbler. Then mix everything. Then take one. Suppose you got 9, the first. Then you take another. Suppose you got 31. Likewise, 100 times you take one each. And you will get whatever numbers you get, that will be your sample. Out of 1 to 1000, you will get lottery method. So lottery method, there is no, every element has an equal chance. Every element has an equal chance. 1 by 1000. 1 by 1000, that is the chance. If there are 1000 elements, you want to take one lottery, then 1 by 1000 is the chance. Now, there is a problem. Now when you draw the first number, when you got 9, the possibility of selection is 1 by 1000. Now the total has become 999. One has gone out. Now when you draw the second one, the possibility of selection will be 1 by 999. Now when 2 you have selected, then it becomes 998. The third one will be 1 by 998. Similarly, it will be 1 by 997, 996. So you see, here it is having less chance of being included. Here it is more chance, little more chance, little more chance, little more chance. But when you draw the 100 number, that will be 100 out of 901. So here it will be more chance of being included. So lottery method also, there are two ways. One is lottery method with replacement. And another lottery method without replacement. This is without replacement. If you have taken one, you are not again including in the tumbler, in the tumbler or whatever bucket, and you are drawing 100, 1 out of 1. That is without replacement. So the chance of being included is getting more and more. 1 by 1000 for the first, 1 by 999 for the second, 1 by 998 for the third, 1 by 997 for the fourth, 1 by 996 for the fifth, likewise. But the most appropriate method will be lottery method with replacement. 1000 will be there, numbers, you draw 1. Suppose you got 9. You write down that number. Then again fold that 9 and include it, add it in the bucket. Again mix. Then draw the second one. So the chance will remain always 1 by 1000. Suppose you have got once 9 and in the 39th attempt you again take 9. Then you do not consider. You fold it and again put it back. So till you get 100 elements, you draw lottery. That is lottery method. And studies have suggested that this is the most appropriate simple random sample. Through lottery method, you never know which will be included, which will come. That is not in our hands. Or nobody can say. So the lottery method is the most appropriate method of drawing a simple random sample. So, the lottery method is perhaps the most appropriate method for drawing a simple random sample, whether through replacement method or without replacement. Second comes LHC Tippett's table. Now, LHC Tippett is a social scientist and also a statistician. What he has done, he has prepared a list of about 10,400 4-digit numbers from about 41,600 digits from the census records, and arranged all these 10,400 4-digit numbers in a very random way in different pages. The Tippett's table, what it is called, might consist of about 60 to 65 pages of all randomly arranged 4-digit numbers, around 10,400 numbers. Now suppose I told you regarding the Tezpur University students, the number of students, the population was 4,000. Now, we want to take a 10% sample. Suppose 10% is 400. Our sample we want to draw is 400. Now, according to the Tippett's table method, what he says, it is not necessary that you should start from the page 1. He says that you open any page. Let it be 39, let it be 61, let it be 9, let it be 1. And open any page, start from the top left corner and look at the numbers which are less than 4,000. Which are less than 4,000, because our population size is 4,000. So 4001 we will not look for. It should be from 0001 to less than 4,000 or 4,000. From the table, suppose you got about 29 numbers which are less than 4,000. Then you go to another page. Open another page of the table. And in that page, you look at for numbers which are less than 4,000. Suppose in that page, you got about 112 numbers. Then you open another page till you get the sample of 400. So you open 1 page, 2 page, 3 page, 4 page, 5 pages or 6 pages till you achieve your sample size, that is 400. So the numbers are randomly arranged. If you ask me, how can we say that that is a random sample, then I do not have an answer. It is only from the experiments that have been done for ages together, it has been verified and concluded that a sample drawn by using the Tippett's table or the Tippett's number always turns out to be a random sample. So I will not be able to give justifications, but the studies, the books say that from experiments that have been done, the research studies that have been done over ages, and the method of drawing a random sample by using the Tippett's number or Tippett's table turns out to be really a random sample. So we can also make use of the Tippett's table to draw a simple random sample. Third is grid sampling. It talks about the area. Now, if we want to make a study of the whole of Assam, and for a student like you here studying in one department, the Department of Mass Comm, it might not be possible for you to go to all the districts or all the blocks, all the tehsils of Assam and collect information. But the coverage should be total of Assam. All corners of Assam should be included in your sample. Then what we do? A grid. A grid is normally a plastic sheet having squares. It is having squares with the horizontal and vertical straight lines on a plastic sheet like this. It will be having various equal squares. And you have the map of Assam. You have the map of Assam. Now what you do, before looking at the map, you arbitrarily, randomly you select some square. Suppose you have selected this one, and you have selected this one. You have selected from center this one, and here this one, and you have selected one. Here you selected one, and here you have selected one. These 7 squares we have selected, and then you have the map and put this plastic grid on the map of Assam, and whatever squares you have marked already, the areas which are coming under those marked squares will be your area of research. will be your sample of research. So this is known as geographical area, or through grid table you can identify the areas and the households of research for your study. This is also randomly done. So no one can say that there is personal biasness or prejudices. We, without looking at the map, we select squares on the grid, then we put that grid on the map, and whatever area that comes under, we do not know whether that square will take on to Dibrugarh, or the other square will take us to Nalbari, other square will take us to Tezpur, other square will take us to Bhalupang. We do not know. But after the placement of the grid on the map of Assam, we will be able to identify the area, and that is really will be a simple random study, simple random sample when it comes to geographical areas. And that is known as the grid sampling method. So these are the three basic methods of simple random sampling. I hope you have understood how simple random sample can be drawn from a definite universe or a defined universe. And to draw a simple random sample, I already told you that a defined universe is a must. If you do not have a defined universe or a finite universe, then it will not be easy to draw a simple random sample. Now, the second method of probability sampling I talked to you about is systematic sampling. Systematic sampling. This is a variation of simple random sample. Now, there are also some disadvantages of simple random sample. When you draw a lottery, some portion, some numbers might be left also out of the sample. Now, if the size of the homogeneous groups, the various strata in the homogeneous strata in the universe are not of equal size, they vary in size, then it might so happen that the smaller homogeneous group might be left out of the sample. So systematic random sampling is an advanced method of drawing a simple random sample, making it sure that each group of the heterogeneous population would be represented in the random sample. And the systematic sampling is very simple method. Now you have a list of 1 to 4,000. As I have told you that it is the universe size, and you want about 400. This is the universe, this is the sample size. I had told you in the earlier class about this sampling interval, and universe divided by sample size, it is come to this is known as sampling interval. Sampling interval means every 10th unit would be included in the sample. Now, 1 to 10, so from every 10 units, 1 unit will be included in the systematically drawn simple random sample. How we will do it? How we will ensure randomness? So what we will do, 1 to 10 we will write, and from that we will, through lottery method, we will take one number. Suppose we got 3. Then the sampling interval is 10, and the numbers that we will choose, 3, then 13, then 23, then 33, then 43, then 53, then 63, 73. Likewise, we will last go to 3,0993, and these will be 400 units which will form the sample. So the sampling interval is 10, means 1 out of 10 will be included in the sample, And from the first 10, we have taken a number through lottery method on a random basis. We don't know whether the lottery method 1 will come out or 2 will come out or 3 or 7 or 5 or 9 or 10. We don't know. So complete randomly we have chosen one, and then through that interval we will select the other units. So it is considered to be a systematically drawn random sample. And here that is also proved as a very appropriate and scientifically proven method of drawing a simple random sample. And this is called as a variation or advanced variation of the simple random sample. Now, then the third method, I am sure you have understood the systematic sampling method, because it is just a variation of the simple random method, and rather a variation which gives us little more randomness without giving us an opportunity of missing something. Third, I told you about the cluster or area sampling. Cluster, what do we mean by a cluster? Cluster is a group of units bound together from which we will draw the sampling units. Area. Now suppose you are doing a study on the on the population of Sonitpur, or you are doing a study on the media usage habits of Tezpur, the residents of Tezpur. And then how would you draw the residents of Tezpur? It's about 30,000 people are living in Tezpur. 30,000 people are living. And you can study within these 2-3 months, you can collect data from only 300 people, not more than that. But if you are able to draw a representative random sample of 300, then your findings will be as good as the census findings of a study of 30,000 people. So this cluster or area sampling says, now Tezpur has been divided into, say, 16 wards. We have a municipal corporation and there are wards. And a ward is a cluster. A ward consists of several streets. And so some of the streets constitute a ward. So every ward would be constituted a cluster or an area. And from these 16 wards, you can, on a random basis through lottery method, you can select 4 wards for your study. 4 wards. And from each ward, you can select 100 people from each ward. 100 people on a random basis. Then your sample of 300 or 400 you will be able to draw. This is known as cluster or area sampling. And we do not know exactly, we do not have a very, very definite universe. Now, drawing a definite universe of 30,000 population, no doubt, in the census we have, but in the census normally we get data about the households. Now here what we can do, we can select the households, and in every household we can collect data. Suppose in one house there are 5 people, in another house there are 3 persons, in another house there are 7 persons, but out of which 4 are below the age of 3 or 4. Then only the adults will be able to we can collect data from. So take the households, 10 households from each ward and collect your data, and that will be random sample. That will be a random sample. Means you have chosen the clusters, you have chosen the areas on a random basis, you have chosen the households on a random basis, and the people, those who are living in that house, you don't know them, and those have been included, and you have collected data from 300 people living in those households which you have identified on a random way. That is known as the cluster or area sampling. The most important method of sampling is the stratified sampling. In social science research and particularly in communication research, stratified sampling is very important method of drawing a representative sample. Stratified. What do we understand by stratified sampling? Stratified means the whole population has been divided into various strata depending on various characteristic features of the population. I gave you the example of studying the media usage habits of the students of Tezpur University. So the population here is Tezpur University students. Now stratified means we will have to create different strata of groups of students with different characteristic features. I will tell you. First, we will say Tezpur University students belong to four schools. One is science, one is management and commerce, another is engineering, another is humanities and social science. So our population has been divided into four strata, four groups. Then a further stratification. Science, suppose we have 5 departments. Department of Energy, Department of Molecular Science and Molecular Biology, Department of Chemical Science, Department of Mathematics, suppose Department of Physics. Let us say, for example, 5 departments. Now under Management and Commerce, we have 2 departments. One is Management, one is Commerce. Now under Engineering, we have 4 departments. Say one is Computer Science, one is Electronics, one is Mechanical, one is Civil. Okay? Now under HSS, we have say English, Sociology, Social Work, then Cultural Studies, then Journalism and Mass Communication and Journalism, and then say Assamese Studies. Suppose we have these 6 departments. 6, 4, 10, 2, 12, 5, 17. Say for example. Now how many strata we have created? TU students, the first stratum is according to their schools. Second stratum is according to their departments. Then third strata we will create. TU, Science, and then Energy. We will have now male and female. TU, Science, Energy males. TU, Science, Energy female. TU, Science, Molecular Biology male. Molecular Biology female. Chemical Science male. Chemical Science female. Mathematics male. Mathematics female. Physics male. Physics female. Here how many? You have created 10 strata. First strata, second strata, third strata. Third you have got 10. Similarly here 4. Male management, female management students. Then commerce male, commerce female. Similarly, now we will have out of 17, there are 34 strata. 34 strata we have created. Now, we can also create further. How can we create further? Now, out of males, we can say, if they are, suppose, males coming from northeast, males coming from other parts of India, and males coming from foreign countries. These are the three strata you can create for every stratum here. Females from the northeast, females from other parts of India, females from foreign countries. Similarly here. So 34 into 3, you have created 102 strata. Means from the Tezpur University population, which is 4,000, you have created 102 groups, homogenized groups. That is known as strata. And you can choose, suppose you want to have a 400 sample size, then from these 102 different stratas, you can take 4 each. You can take 4 each, then you will get 408 as sample, and which represents every stratum. It represents Tezpur University science student studying science, studying energy, male belonging to northeast. Tezpur student studying science, energy, male belonging to other parts of country. Tezpur University student science, energy, male belonging to foreign nation. Likewise, we have created 102 strata, and there is very little chance of excluding any part of the population. So it is considered to be truly representative. It is considered to be truly representative. Now, this stratified sampling also, it is of two types. One is proportionate stratified sampling, another is disproportionate. Proportionate means if we take 4 from each stratum, then it is proportionate. Now suppose in the management we have males of 108 males and females are only 20. Then if we take 4 from here and also 4 from here, it will be disproportionate. So here what we can say, we can take 3 from here and 1 from here. Or out of 8, suppose 4, then we can take 6 from here, 2 from here. This is known as proportionate. Means according to the size of their existence in the various strata, we are taking proportionately. If there are more students from northeast, we take more from the northeast. If there are very less students from other parts, we take only 1 from the other parts. If there are no students foreign, we leave it that blank. Similarly, but if we take 4 from each, then that is disproportionate to their size of existence in the population. So, according to their size, we will have to take. That is known as proportionate. Proportionate stratified sampling is again a very important method of drawing a simple random sample, equally giving equal chance and equal weightage to the various strata that we have created out of the heterogeneous population, taking into account few homogeneous characteristic features, and this perhaps the proportionate stratified sample would be the most appropriate type of simple random sample, and the findings from this representative sample will certainly be able to universalize for the whole population. This is stratified sampling, proportionate, disproportionate. In the next class, we will talk about the multi-stage sampling and quota sampling, and also about the non-probability sampling method. Thank you.